Good morning, everyone. I'm really excited to be here. Scala Days is one of my favorite conferences, so thank you for having me back. Like he said, my name is Kelley Robinson, and I have spent most of my career working in Scala, including about 3 years doing data engineering with Apache Spark. And we were doing that in an advertising technology company. I started there in about 2015, and at that point we were using Spark maybe 1.1. And so it was a really, really early project at that point, and it's been really interesting to see how the project's developed since then. As you can imagine, ad tech has a lot of data, so I spent most of my time at that company writing our data pipelines for our extract, transform, load, or our ETL pipelines, and all of that was done using Scala and Spark. And it's really fascinating for me to see how many people are interested in Spark at this point, especially since the project has really only been GA for about 3 or 4 years. So quick show of hands, who here actively uses Spark? Who here has dabbled with Spark? All right, cool. And who here has written no Spark? Oh, wow. So good balance of people. This is going to be a great talk for all of you. It introduces some of the fundamentals of Spark, and it also gets into some of the new abstractions that even if you've been working with Spark for a few years, you might not have seen yet. So I got out of ad tech about 6 months ago. These days I am a developer evangelist at Twilio, where I get to work on a lot of cool and interesting things. For those of you that are not familiar, Twilio is a communications company, so we make APIs that allow you to add things like text messaging and voice calling, video chat, and things like two-factor authentication into your applications. With identity being so closely tied to phone numbers, Twilio acquired Authy in 2015, which most of you may know is a two-factor authentication provider. And this is the kind of stuff that I work on every day. I work on our account security products. And this is really the last I'm going to be talking about Twilio in this talk, but since I spend so much of my day thinking about authentication and identity and how we can secure our online identities, and passwords are really the biggest way that we've done that in the last 30 or 40 years. So when I was writing this talk, I needed some data to dig through that was going to be a little bit more interesting than advertising clickstream data, because I don't know about you, but that's not the most fascinating thing to me. And fortunately or unfortunately, we have about 500 million breached credentials that we can dig through. And so that's the stuff that we're going to be looking at today. We're going to start by introducing Apache Spark, look at why people are using it and how the project has developed. I'll give a bit of background on the state of passwords before we dive into the data. Then I'm going to show you how Spark works with a little bit of live code. And then finally, we'll spend some time talking about the implications at the intersection of big data and security. But let's start by looking at the Apache Spark project. So Spark markets itself as a fast, unified analytics engine for big data and machine learning. It provides a functional interface for doing a lot of the computations on top of that. And it does that with languages like Scala, which is why we're all here, but it also has APIs for writing in Python, SQL, R, and more. It's generally thought of as an improvement on top of Hadoop and MapReduce. In fact, it was built on top of Hadoop and MapReduce. And depending on what you're doing, it's about 100 times faster than Hadoop and MapReduce, which is why so many people are moving to Spark now. Any kind of big data job that they were running 5 years ago can now be done in Spark in a fraction of the time. When we talk about big data, I mean data that can't fit on a single machine, though machines are getting bigger every single day. So thanks to Gary Bernhardt, we know that there are Amazon instances that are enormous now. So maybe you don't even need Spark. We can all just go home, write a Python script, end of talk. Just kidding. So there are some companies that, of course, are doing this kind of stuff at petabyte scale. And as our machine capabilities grow, so does our data. We are all very concerned with data these days, and we're storing more and more of it, even with EU regulations being what they are. But I just want to include this because when people ask me about big data and tools for big data, one of the things that I often say is how big is your data actually? If you're dealing with even several, dozens of gigabytes of data, there's a good chance that you can run that on a single machine. One of the major benefits of Spark, though, is that it has built-in support for multiple languages and extensions. And so I mentioned some of the languages that it supports. Again, we're all familiar with Scala. But it also has built-in libraries for things like streaming data and machine learning. And it's really promoting its capabilities for machine learning lately and AI. The Spark Summit that's coming up is like the Spark and AI Summit. And so they're really, really leaning heavily into that. But as my friend Ryan likes to say, machine learning is just the carrot that you dangle in front of engineers to get them to do data engineering. And so it's one of those things that in order to do that kind of analysis, you really have to clean your data first. You have to get your data in a format that's going to be useful to you. And that's where Spark was going to come in both fronts. And that's one of the things that I really appreciate about Spark is that even though they are investing in the machine learning tooling, it also is a really good platform for doing the data engineering side of things. There are two main abstractions for Spark, and so these are some of the things that you're going to be dealing with in every piece of Spark code that you write. We started with RDDs, or Resilient Distributed Data Sets, and those are not going away. I want to make that clear, but they're moving towards something called data frames and data sets. And for several reasons, these are going to be preferred nowadays, and we'll get into some of those reasons in just a little bit. Completely unrelatedly, I just have to rant about the fact that they were not consistent with the camel casing of these. This is not a typo. The F is capitalized and the S is lowercase, so I can never remember which one's which. Thank God for IDEs, but still. It's an inconsistency that drives me mad every single day. But RDDs, let's talk a little bit more about what those do. So they are distributed collections with functional operators, and they have a functional API for working with them that's going to be very familiar to a lot of Scala developers. And so you can see how we're doing a count with a flat map reduce function here. And the code example that we're using here is going to be doing that basic reduce method, and that looks a lot like Scala code, even though a lot of these APIs are specific to the RDD. Like I mentioned, RDDs aren't going away. They still have their use cases. But there were some problems that we had with RDDs. And even though Spark was easy to use, people were running into these roadblocks occasionally and doing some unintentionally very bad things. And one of the big things that people were doing was using methods like group by key. And it turns out that this is really slow and terribly not performant. And there's usually a better way to get what you need. But this is from a Databricks best practices guide. Databricks, for those of you that aren't familiar, is the company that kind of maintains the Spark project. The original creators of the Spark project that was created at UC Berkeley as a graduate level studies project of some kind. And then they took that, put it in the Apache incubator, and now have a company around it that offers some managed services. So Databricks is a pretty authoritative guide to things that you would do with Spark. And this is from their best practices guide that they say, don't use this API that we gave you. And so this is one of the faults that you see with things like RDDs is that they're slow. They offer APIs that might not be the best thing for you. And the team was very aware of this, and they were working on ways to make it better. But it's really easy for programmers to fall into this trap, especially in a language like Scala, where you're generally working with an IDE. And so, you're in IntelliJ, you hit dot, and you see this method available, and it sounds like something really useful, and there's no information to you that this is not something that you might want to use. So what they are encouraging people to do now is instead use this data sets abstraction. And they started this by developing the data frames API. And so if you're familiar at all with data frames in a language like Python, Pandas, or R, this is going to be very similar to that. It was modeled on top of that, and so this is the Spark equivalent to something like that. And then data sets were developed on top of that for Scala and Java specifically to offer a strongly typed API on top of the data frames API. And so this abstraction layer, we all love types in our Scala programs, and so this is going to offer you some compile time safety in addition to some of the speed benefits that you get with the data frames abstraction. And this API specifically works with structured or semi-structured data, and it contains a lot of optimizations that make the data and the operations on it much faster than if you're working with RDDs. And because data sets effectively require a schema, depending on what you're doing, they're about 2 times faster than RDDs, which is pretty big if you're doing a lot of operations across your data. So if you're working with any kind of structured data, you definitely want to be looking at the data frames or the data sets API. They also provide a SQL or a SQL-like DSL, and you can see that in this code example. We're doing a group by method and a count on this, and so that's going to be familiar if you're familiar with SQL, which SQL is pretty much the universal data processing language. All the best data scientists I know are really good with SQL, whether they want to be or not. And you can even use raw SQL on top of Spark, which is really cool, and I'm going to show you that a little bit later. So you'll remember this ecosystem and the fact that Spark supports many languages, including languages like R and Python. For this audience, though, I do want to point out that Scala still has the most robust language API. I probably don't need to convince you of this or that you need to use Scala, but it's way faster when you're dealing with RDDs. There's a huge performance gain there. It has strongly typed data sets, while something like Python, given that it's a dynamically typed language, is pretty much always going to have the data frames. I know Python 3 is adding some types, but I think that the data sets API is still going to be most beneficial in languages like Scala. And it's also almost all Scala under the hood for Spark. And so if you really need to dig into the source code, which I've needed to do occasionally, you're going to be looking at Spark or Scala code under the hood. If you need to extend the language at all, the library, there's ways that you can do that with Scala. So one of the big disadvantages early on is that Python was just so much slower than Scala, and so you would have a lot of data engineers and Python engineers that would learn Scala just to improve the speed of their programs. Dean Wampler, if you're familiar with him, has a very popular tutorial that's called Just Enough Scala for Spark. And I think that's really great. It's been the gateway drug for a lot of people to get into Scala. I think there's a lot of people that learn just enough Scala so that they could do the things that they need, because then you don't have to get into Spark engine optimization tuning, which, trust me, if you can avoid Spark engine optimization tuning, you want to. Sometimes learning Scala is easier than learning how to tune Spark, which may say something about the program itself. But one of the interesting things that's good to point out here is that with the data frames API, Python is just as fast as Scala. And so moving forward, this is going to be really interesting to see how the language continues to develop, because there's so many optimizations in Python now that there's not that same motivation to move to Scala as there was previously. And so I thought this tweet was really interesting, and it's in reference to improving accessibility of Spark and Scala for data scientists. And Cameron, says there's a lot of low-hanging fruit here for data visualization, plotting libraries, and he's right that Python and R are light years ahead when it comes to this. And the default languages for people like biologists or any type of other person that's doing a lot of computational data analysis, a lot of times they go to R or Python. And I think in order for Scala to be an accessible alternative to that, we really have to work on the tooling and make it a lot more accessible with the visualizations and the type of things that we're offering to that community. So I'm really excited and interested to see where the data community takes this. Even as a Scala engineer and all the benefits that I just mentioned, I have a hunch that Python might win out here just because they had such a huge head start with this. And Matej, who is the creator of Spark, at last year's Scala by the Bay, his keynote about Spark at a Scala conference, all of his code samples were in Python. And so I think that might tell you something. So that's some of the basics of Spark and where we're at with the project today. I wanted to spend just a couple of minutes talking about the state of passwords, since it's going to inform our data analysis. Like I mentioned, I spend a lot of time thinking about authentication, and we have a big problem, and that's that people reuse passwords. And they use passwords that are short and easy to guess. And the problem is like, even if you don't care if your MySpace account gets hacked, if you were using the same set of credentials as you were for your MySpace account as you are for your email or your bank account, you're going to have a bad time. And you're going to have a bad time because hackers like this guy, and this guy is legit because on top of all that encrypted text, he got the word hacked to read. I love stock photos of hackers. Trust me, Google it, you won't regret it. But guys like this will buy your leaked credentials and implement them across the web in a practice known as credential stuffing. And people are still doing this because they can make a lot of money doing this. They can transfer money out of your bank accounts. They can get access to your email and buy things for themselves and all of that fun stuff that you don't want to happen. And so the reason that we have a problem with passwords is because this credential stuffing is so common and people are using and reusing passwords all over the place. You might think that nobody does this. Nobody writes a password on a sticky note. Nobody has a password as silly as 123456. But of course, there are people that still do. In fact, this password, 123456, has been seen over 20 million times. This is according to the site Have I Been Owned, a project from security researcher Troy Hunt. Side note, Pwned with a P is the hacker way of spelling owned, and if you keep the P silent, people will think you're cool. So Troy Hunt has access to password data from hundreds of password breaches, and he provides an interface for seeing if your password has been included, or password or your email has been included in one of those data breaches. So I encourage you to check out this site. You might find some things that you need to change. And this is the data that I'm going to be using today to show off Apache Spark. So let me just switch over. QuickTime. Oops. Okay, so I'm using a tool called Zeppelin here. Zeppelin's kind of like a Jupyter notebook. It has a built-in Spark interpreter though, and so Zeppelin's a really good way to set up Spark locally on your machine. It's also a really good way for me to demo things for you today. I'm running this on localhost, so hopefully I won't have to rely on conference Wi-Fi. Like I said, it has the built-in Spark interpreter, great for ad hoc analysis. It has some built-in visualizations, and so that's one of the things that I think Scala and Spark is lacking, and this starts to solve that problem. If you've ever used Databricks, Zeppelin is kind of like an open source alternative to that. Databricks is not cheap, and so for my purposes, I was using the open source alternative. If anybody here works at Databricks and wants to give me credit, come find me. And for the sake of time, I've already done some joining of the data. So what is in the owned password data is hashes of passwords, because it turns out that people store a lot of personal information in their passwords. And so Troy Hunt didn't want to make those all accessible in a downloadable file. And so it's a SHA-1 hash of passwords and a count of the number of times that that password has been seen in a data breach. Because there's only so much interesting things we can look at with SHA-1 hashes, I've gone ahead and joined that with some known common passwords. And so I think we have about 700 passwords, and so I'm going to go ahead and read those in. These are in a CSV file, and so we can go ahead and grab that. And we'll go ahead and count the number of those that there are. Like I said, I think there should be about 700,000. Go ahead and save that to a variable. You'll notice here that Spark has a built-in CSV reader, which is pretty handy. And so we can use that to go ahead and read in this data. Once I print the schema, you'll see that it has some columns. It's already interpreted those columns to be these, built-in variable names. But the interesting thing is that we have a header on this file. We just have to tell Spark that it needs to look for that. So with just one line, we can go ahead and get the header names that are there, and then we have a data frame that has this information in the headers already, and so we can start to do analysis on that. The other thing that you might notice is that our count here is a string, and counts, usually are numeric, and so we want to tell it to infer the schema, and then that'll allow us to have the correct types that we want. And so now we have a count as an integer. This is pretty cool. So we've already got some interesting data frame to look at. Before I show you the contents of that data, I have to do something real quick. And that's because people put a lot of bad words in their passwords. This is a professional environment. I don't want those things showing up. So we'll go ahead and read in those. This is just from a text file that I have. I'm not going to show you what's in here. You can use your imagination. So we can go ahead and count these. So this is we wanted to count those and then count our bad words. And I think there's about 67 bad words, and you'll see there's 700,000 passwords. Let's join these together and see how many passwords we get rid of. So we can go ahead and do the join like you would in a SQL, and so we're using the SQL like DSL to do this. And so we can join our bad words, and we're going to do that on if our password column contains any of these bad words. And so we're going to be looking for the value. Value is the default column name. And so for this bad words data set, you'll see that this is a data set of string. And so it has one column, and it interpreted that to be a string value. And then the very important thing is that we want to tell it that this is a left anti-join, which means leave out everything that's in this thing that we're joining it with. And so now if we do this count, hopefully we can see that there are about 20,000 less passwords than the data set we were working with. So that's kind of interesting. Do with that information what you will. So now that we have this, we can go ahead and show our most common passwords. And we're going to be doing this by ordering by the descending count. And we have a built-in method called show, which will do this in a table view so that we can see the passwords, the most common passwords. And so this is exactly what you would expect. Numeric sequences, the word QWERTY, ABC123, all these very obvious passwords. I love you. Oh, that's nice. But still, you know, if you have any of these as your passwords, maybe it's okay. I think the common example that I hear is if it's your pizza login, maybe you don't care if anybody gets access to that. But you can also think about the fact that even with your pizza login, somebody can get access to your home address. Somebody can get access to your phone number. And those are things that people can use to hack you. So keep your passwords strong. That's the one thing that I want to leave you with here. So the other thing that I want to show you here is, so our data frame for passwords is still a data frame. It's not our strongly typed data set. And so we can go ahead and make that a data set by declaring a case class. And so I'll name this like password hash, and we're going to have a password, which is a string. And the hash is also going to be a string. And then our count is going to be an int. And then all you need to do in order to tell it that this is the type that you want is declare that. And then once we have this, we'll have a strongly typed data set of password hash. And this is useful because then we can go ahead and do things like filter on the types. So we could filter on anything that has a count greater than 5,000. And this is going to be really useful depending on the type of analysis that you're doing, because this is going to start catching things at compile time instead of catching things at runtime. And so the alternative for doing something like this in Spark, if you don't have the data set, is you're doing that kind of column access that you saw me do with this notation. And so that's how you would access a column. And so you can also do things like you could do a where clause on this. And so you can write some raw SQL in here. So you could do where count is greater than 5,000. But if you accidentally misspell that as conut, you know, you're going to get a runtime error when you're running this in your code. As opposed to doing it, you know, with this method, you would get the compile time safety. And so that's one of the things that is the benefit of having data sets in your Scala code for stuff like that. All right, so that's we've got our data loaded in, and now we can look at some of the things with the data. One of the things that I want to look at here is the most common lengths of passwords, because I think that's pretty interesting. And we're going to do something first to give all the most common lengths to our data. And so I'm going to go ahead and add a column. You can do this with Spark SQL. And so I'm going to call this column len, and then we can use the built-in function for length to get our length of our password column. And then we can go ahead and add that. And then once we have this, we can do something cool, which is running raw SQL on top of our data. Let me make that a little bit bigger. And so what you can do here is write the SQL like you would expect to. And so I'm going to select our length, the sum of our counts, and we're going to be selecting this from our passwords table. And then we're going to group by and order by our length. And that's because I didn't save this. And so you have to create a temp view and give it a name. Let me put that on a new line. And this is to help it do some indexing so that you can run the raw SQL query on top of it. And so this is being done with Zeppelin and the Spark engine. And so now we can run this, and it'll give us some information about what our most common lengths are. And the really cool thing about this is that it comes with some built-in visualizations. And so you can see things here, like it offers a bar chart, a pie chart. I don't know when pie charts are ever good, but you can think of when scatter plots might be necessary. I think our bar chart for this data is pretty interesting. You can see that our 6 and 8 character passwords are the most common. This makes sense to me since a lot of password minimums are 6 and 8 characters, and so that's where you're going to see a lot of people adding in those password lengths. Some other cool things that you can do with this is you can add in where clauses. So you could do where password, like we'll do Berlin. And so you could do this like with all the raw SQL that you could imagine. But then one of my favorite things about Zeppelin is that it does this cool thing where you can do these placeholders. And so you basically give it a variable name, and then you have this password field that comes up. And then you could give this report to somebody on your, management team, or somebody that doesn't want to write any code or doesn't know SQL. And then you could have them replace this with something like Kelley or Scala. There's a lot of people that use Kelley in their passwords. That's very exciting. I don't think those 8-character passwords are the word Scala, unless all of you are writing Scala 1, 2, 3 as your passwords. All 8,000 of you. I think that's pretty interesting. I bet that those are all Martin's passwords. Don't tell him I said that. But yeah, so that's pretty interesting. And I think this goes back to some of the really great things that we want to encourage about our data processing and tools moving forward, is that these visualization tools for any kind of data processing are super, super awesome. And as much as we can continue to develop these, we should. All right, so we've looked at the length of passwords. One of the other things that I want to take a look at is kind of the contents of the passwords themselves. And there's a couple of different ways you can look at this. I think looking at proper nouns is a really obvious thing that you can attack, and you could do that with like celebrity names or geolocations. I'm going to look at dog names because I love dogs. And so I have a JSON file with some common dog names, and we'll go ahead and read that in. And so this will have some information in it. I forgot to save the file. So this is the dog JSON file that we have. And I think this is really interesting because I have this one line that has chicken, or Max's favorite food, in there. And so just because that one line has food in it, it realized that the schema had that property. And so it inferred that we had those 3 columns. And if I take that out, it's a corrupt record because Spark expects these to all be on one line. So if I take that out and rerun it, it'll know that there's only 2 keys in there that we're expecting. And this is really useful because, especially if you're dealing with hundreds of millions of log lines every hour, or whatever your data scale is, it's really hard to have any kind of idea about the consistency of what's in that data. And so this is one of the really brilliant ways that Spark comes up with to do that data inference and the schema inference for you. You don't have to worry about that as much as you otherwise would have. And maybe you're still going to have your own encoders and decoders so that you can perform business logic and have some idea of your expectations of the data. But this is also a really interesting way that you can help inform what those encoders contain, so that you can build those more smartly and maybe get some error identification or notifications in your tool set about if you're getting data back that you didn't expect, other than just suppressing those. So I think that's pretty cool. Now that we have our dogs, we can go ahead and see how many passwords contain our dog names. So let's go ahead and join those together again. And this is going to look pretty similar to the join that we did before. We're going to look at if our password contains the dog name. But this time we're not going to give it a specific join type because the default join is going to be an inner join, and that's what we want to do. And so any guesses what the most popular dog names and passwords are? We'll go ahead and order that by descending count, and I'm just going to go ahead and select the fields that we care about, which is the password, the name, and the count. And we'll go ahead and show that. And so Charlie is our most loved dog name, apparently. That's good for Charlie, probably not good for Charlie's owners. You will notice that this did an exact string match on this, and so if we wanted to be looking at lowercase names, there's a way that we can do that, and that's with something called UDFs, or user-defined functions. And so we want to define one that's lowercase. We used a built-in Spark function earlier for the length. Lowercase is not a built-in Spark function, and so we can go ahead and define that ourselves. The syntax for this is a little different than Scala definition syntax, but it should look familiar enough to you. And so we'll take in our string, and then all we need to do is lowercase that. And now we have a lowercase UDF, and we can go ahead and add that here. And now I think the results are pretty similar, but you will see even more passwords because people are more likely to type in lowercase things. So 278,000 people using Charlie the dog, maybe that's a kid too, in their passwords. So that's pretty interesting. I'm going to stop this section here because there's a couple other things that I want to get through still. Let me make sure that this is going to look okay. Beautiful. All right. If nothing else, I think that we can all agree not to include our dog names in our passwords. This entire talk was just an excuse, and every talk I give is an excuse for me to put a dog rights tweet in there. I did modify this one, but this is the best account. Please go follow it. So, these including proper nouns and names in your passwords is not as clever as you might think. It's a very common way for people to remember their passwords, but there's other ways that you can create memorable passwords that are not as insecure as is something like including your dog name. In all seriousness, though, some of the major benefits of Spark and some of the things that I hope I illustrated with that demo is that it's not only fast and flexible, but it's really useful for quick data exploration. And I love how quick it is for data exploration. Having worked on combination data science, data engineering teams before, this tool is incredible for having a common language between those two functions. And if anybody's worked in those functions before, you might know how difficult it is for you to work with data scientists if they don't speak the same language as you. And that's, metaphoric and literal, because if they're writing all of their models in R and Python and your entire data infrastructure is in Scala, it can be really hard to translate that over. And so if you can get on the same platform, it's a huge step in the direction of making your team more productive overall. And I think that's one of the big advantages that Spark is going to have, is that it provides that tool set for doing both of those things together. Of course, Spark is not without challenges. I do want to highlight the challenges in operationalizing, since it's relatively easy for me to stand this Zeppelin instance up on my local machine. If you're doing that on a 100-node cluster, it might be a little bit harder. But the whole benefit of working with something like Spark is that you can run it on distributed data. It's just not as easy to do that as what I just showed you. And it's still a young project. The tooling is still being developed. And I do want to highlight some of the things that people are doing to make this easier. For one, Heather Miller just wrote a blog post on how to launch Spark on a cluster. And so that's linked in the slides, and I will post these later. And this is really useful because that didn't really exist before last month when Heather wrote that post. And so there's other things that people are doing to improve the operationalizing the opaque error messages. Holden Caro gave a really good talk. I see Holden in the back. Last week at PyCon about how to debug PySpark, and Python developers have an even more challenging journey than Scala developers because they've got Python stack traces nested in Java stack traces, nested in Python stack traces. Unfortunately, we only have Java stack traces, but it still can be a little challenging. I included this error message so you can see what some of these stack traces look like. We can spend a little bit of time on this. This is an error message from something I was running on my own machine. And so you can imagine when you start running this on large clusters, you get all these, node executor lost errors that are really challenging to debug if you don't know the right place to look. And there's work being done every day to make these a little bit better, but this is still something that's a big challenge of working with Spark. And with regards to documentation, I definitely want to call out the documentation that Jacek has compiled. And so this is not part of the official Spark documentation, but this doc is the Mastering Apache Spark, and he has a companion Mastering Apache Spark SQL guide. And so this is really, really awesome stuff. As soon as I found this, it was immediately bookmarked. And some of that syntax that you saw me writing with like the dollar sign for accessing columns, the way that you compare things in where clauses, there's like triple equals that get introduced, and none of that is super intuitive unless you've been introduced to the documentation from somewhere else. And this is one of the really, really good guides for doing that. If you're part of the Spark community, working on the documentation is always a great way to become more familiar with it, and I encourage you to help out there. Finally, I want to leave you thinking about some of the security implications of working with big data. I think this whole talk has kind of revolved around these things a little bit, but there's a lot of things that we need to be considerate of in 2018. Big data is a really useful tool for finding bad things, and it's a useful tool for gaining insights into your business, but you want to keep in mind that you could be part of the next data breach. So this Dilbert is almost too real, a little too painful. Data privacy is on everybody's mind lately, and whether that's GDPR, which as I say that, I see those of you that are cringing because that's all you have to think about. GDPR, obviously, we're in Europe right now. Most of you are probably very familiar. The data privacy law in the EU that goes into effect on May 25th, coming right up. And this is why you've been getting all of those privacy policy change emails lately. So all of these companies are doing all this work to become compliant, and that involves updating their privacy policies. You see companies that are just straight up shutting down because all of their business was relying on selling your data, and now they can't do that anymore. So I think it's really interesting to see the evolution of things that are happening. All of the data breaches that are being revealed right now, part of that is in order to be compliant with GDPR, you have to reveal the data breaches within like 72 hours or something. And so people are getting out in front of that in order to maybe be lost in the noise. Maybe that's their goal. I don't know. Our strategy is to wear them down, right? So, we can think about things like GDPR, Cambridge Analytica, the Equifax hack. These things are happening so often now that it's really hard to forget about the implications of security and privacy. And we really can't separate for security from development, especially when we're working with any kind of data. So as engineers, we need to be mindful of the data that you store and how we're accessing it. And that's because nobody's security is perfect. And so if you have any influence over the security at your company, including if your company is too small to have a dedicated security team, make sure you're storing passwords and other personally identifiable information securely, and be an advocate for not storing more data than is necessary. Sometimes executives come in and say, store all the data, it might be useful for analytics later, but honestly that can cause you more headaches down the line, and that's something that security experts often recommend, is simply not storing more data than you need. All of that password data that we looked at is accessible because it was stored in a way that made either decrypting it or accessing it available in plain text. And so those are all data breaches that are unfortunately now available to us because there was not great security around the way that data was stored. And so this tweet, if you haven't seen it, it was revealed that T-Mobile, or at least T-Mobile Austria, was storing plain text password data. And unfortunately, the support agent really doubled down on the impossibility of that being a problem, which you don't want to do. You don't want your company to be like Kath. So that's from the company side of things. From the consumer side of things, I might be preaching to the choir in an audience like this, but please use a password manager. You can use something like LastPass or 1Password, turn on two-factor authentication, and wherever possible, use an app like Authy instead of SMS2FA, because it turns out that SMS2FA is also not terribly secure. And those two things alone will do an enormous amount to protect your identity and secure your online presence. And as engineers, one of the things that we can also do is encourage our friends and family to use tools like this too. These are consumer applications that are really accessible to anyone regardless of their technical background. And this is something that we can do, is encourage our parents and our siblings and our aunts and uncles all to use these tools. My dad uses a password-protected Excel spreadsheet to store his passwords. Honestly, I'm like, go dad, that's pretty good. Because the important part there is that the security mindset is there, and that's often the hardest hurdle to overcome, is that people just don't think it's a problem. And so we'll get him using LastPass soon enough, but I'm pretty proud of the steps he's taken already. So thank you for letting me spend some time with you this morning, diving into Spark through the lens of own passwords. I love chatting about this stuff, so hopefully I've inspired some of you to dig into your own data with Spark. If you have big data, I think Spark and SQL are great tools for doing a lot of powerful analysis. Like I mentioned, I'm really excited to see how the project continues to develop and what people will use it for. I've also decided this lady hacker skeleton is my alter ego, so that's why I like closing with this slide. I will post these slides to my Twitter right after I'm done here, and I'm going to have a tutorial ready on the Twilio blog pretty soon to show you what I did. Come find me after this if you want to talk about Scala, Spark, or security. I'll be hanging out here for a little bit, or I'm also at the Twilio booth back by room 5. Once again, my name is Kelley Robinson. Please use a password manager, and thank you for listening.
Thank you very much, Kelley. I think we have some time for questions now. Are there any who want to ask something? Okay, there's one.
I would like to ask how the type inferred in the JSON file when you process it with the Spark.
How Spark does type inference from JSON files?
Is it based on the not JSON, sorry, CSV files?
Mm-hmm. That's a good question. I don't know fully the mechanics of how that works under the hood. If anybody here knows and wants to chime in, Holden knows. So I will let her take that answer. This is my strategy for doing Q&A, is I make somebody else in the audience answer.
Yeah, so this actually changes between different versions of Spark, but it samples the rows and it looks at the columns. If you don't have infer schema set to true, it just assumes everything's a string. But if you have infer schema set to true, it will do some basic sampling, and you can configure the sampling if the inferred schema is garbage. But normally it works out okay for CSV files. For JSON, it's normally the one where you have to tune the sampling. If you want to see the code, come find me.
Any more questions?
One on the front.
Okay.
Can you wait for the mic?
Could you say a bit about clustering in Apache Spark?
What do you mean? Like how to deploy on a cluster, or?
Yeah. How do you set it up?
So I'm going to point you to Heather's tutorial there. You basically have to have some kind of cluster management tool. And so you need machines that you're going to be able to process the data on. And then you need something like Yarn or Mesos or some kind of resource manager that's going to work with the master node to be able to delegate processes to all of the worker nodes. And so the way that we were running that in my last company was using Amazon's EMR, which is Elastic MapReduce, and that's a tool that you can run with Node or Mesos to do some of that stuff. There's tools out there for this too, and there's also enterprise solutions that allow you to do this. And so things like Databricks allow you to do this without having to do all of the cluster management yourself. They will do that for you, and that's kind of their value proposition.